All right, looking at this expression, A plus B plus A plus B. Does anybody think they could come up with something that would be equivalent to that? Joey? 2A plus 2B. Totally would work. Anybody think of anything else? Yeah. A plus A plus B plus B. Should be doing this with this. Anybody think of anything else? Hunter? You're right, and you're right. A times 2 plus B times 2 would be kind of the same thing, just a different order. Totally right there. Another way I could look at it, this is A plus B plus A plus B. So how many sets of A plus B do I have? Yeah, 2. So I could say I have 2 sets of A plus B. All 3 of these are equivalent to each other. How many A's do we have? Cole? And Jada, how many B's are there? 2. So if I'm looking at this expression, 2A plus 2B, what we're going to look into doing here is what's called factoring the expression. So can I add A plus B? 2A plus 2B. Can I add those? You said they're not like terms. So this has an A, this has a B. They're not like terms, so I cannot add those together. Sometimes you're going to have to identify equivalent expressions, or maybe having it in a different form for whatever reason is going to be easier to work with. So we're going to work on factoring from this. What is the same about 2A plus 2B? Yes? Okay, there's something else though. And it kind of goes back to this. How many A's we have and how many B's we have. Jaden? So 2A could be written as 2 times A, which is I think what Hunter said, plus 2B could be 2 times B. So I'm what's called factoring out the 2 because they both have a 2. So a different way I can write it is 2 times A plus B. I have A left plus B. So I factored out this 2, and I'm left with A plus B. This process is called factoring. Okay, when you guys kind of came up with stuff at the beginning, you came up to things very similar to this. This is as far as we need to go if you want to factor it. But I want to show you this 2 sets of A plus B would be A plus B plus A plus B. 1 set, 2 sets. So all 4 of these are equivalent. This is the version that we're looking for. I have 2 sets of A plus B. A plus B plus A plus B. A plus A is 2A. B plus B is 2B. All of these are equal. 2 times A is 2A. 2 times B is 2B. 2 times A is 2A. 2 times B is 2B. A plus A is 2A. B plus B is 2B. All of those are equivalent to each other. This process is called factoring. Now, we looked at factors at the beginning of the school year. Anybody kind of remind us, like, anybody know any factors of 30? Doc? 15. You're right. And 15 times what is 30? 2. Olivia? 3 times what? Hunter? 5 times what? And then I think we got 2 more. Cole? 1 times 30. So factors are the numbers that go into another number, right? Those are what factors are. And I did that so that you could kind of refresh your brain. Oh yeah, I do know what factors are. 1 times 30, because they both go into 30. 2 times 15, make 30. 3 times 10, 5 times 6. Those are factors. And I'm going to use that because these directions say use the GCF, the greatest common factor, to write these equivalent expressions. So looking at this next one, 3F plus 3G. Is there anything in common between those? 3F plus 3G. Jada? So you're saying I cannot add these because one has an F and one has a G. You're totally right. But there actually is something that can go into both. They do have a common factor. Daniel?
3FG or 3GF?
I'm sorry, one more time?
3FG or 3GF?
Well, if I wrote something like this, 3FG, that says 3 times F times G. And this is telling me to add the stuff, right? 3 times F plus 3 times G. So since this has an F, you're totally right. You're totally right. So I want to take one more step before we get there, but you're totally right where we want to be. So when I'm looking at 3F plus 3G, the thing that's in common is they both have 3. 3 times F makes 3F. Bring down my addition sign. 3 times G makes 3G. So I'm going to factor out the 3 because they both have that in common. And Daniel said it would be something like 3 times, or open parenthesis, what's left is F plus G. These are equivalent to each other. This is the process called factoring. This is your original expression. This is it factored. 3 sets of F plus G says if we expanded it, anybody know what that would look like? This is as far as we need to go most of the time, is right here, just so we can get a more solid foundation.
If you are in EcoHope or Student Council, would you please report to the gym? EcoHope, and Student Council.
Okay,
Please report to the gym.
so 3 sets of F plus G, what would that look like? 3 sets of F plus G. Olivia? And, you know, if I'm not sure if this equals it out, I can do something like this to check. F plus F plus F is going to be 3F. You know, G plus G plus G is going to be 3G. So I know that they're equal to each other. Questions so far? All right, so let's look at one other one. Six x plus 9y. Now this one is maybe not as obvious as some of the other ones might have been. What is in common between 6x and 9y, or what is their greatest common factor? Nikki? 3 goes into both of them, right? So 3 times what is going to make 6x? Gavin? 2x. Bring down my addition sign. 3 times what is going to make 9y? Jaden. 3y. So I noticed the 3 is the same, and I did that on purpose, right? That's the greatest common factor between 6 and 9 is 3 is the biggest number that goes into both of them. So then I can rewrite it out. 3 comes from here, times, because there's times, 2x plus 3y. This one is our factored form, and this is typically when we're factoring as far as we need to go. For the sake of you guys getting a better solid foundation, 3 sets of 2x plus 3y, what would that look like? Go ahead, T. Titus.
So 2x plus 2x.
Okay, can you write, but could I write it out like this?
Okay, 2x plus 3y plus 2x plus 3y plus 2x plus 3y.
So he had said I got 1, 2, 3 sets of it. 2x plus 2x plus 2x makes the 6x. 3y plus 3y plus 3y makes the 9y. So they are all equal to each other. 3 times 2x is 6x. 3 times 3y is 9y. Yes, sir.
Can you just do all the 2x first and then 3y?
Yes.